Alright, boys and girls, welcome back to the drive-through for a little 7-6 action as we make our way back from the polar vortex express break that we had last week. Hopefully you've you've read this setup for 7-6, but if not, pause the video now and read it closely. As you're going to find is Optima is now going to make rectangular patches for their quilts. Okay? There's nothing to be done on this page other than to read it. Can you find a different expression to represent the area of this new rectangular block? Well, they're saying, can you find a different expression for this? And you said x squared plus 7? You got to foil it. Excellent. Excellent.
So it's x squared.
We got to foil it. It's x squared plus 2x plus 5x plus 10. So it's x squared plus 7x plus 10. So this new quilt block will have 10 additional unit blocks plus 7 bars that are x by 1. Right? We can envision what that means. Okay, so let's say here are some additional new lines of blocks. Find two different expressions to represent the rectangle and illustrate with a diagram while your representations are correct. So, area of this one will be x plus 3 times x plus 4, right? Foil that by distributing, and that's also going to give you, so that's area of x. It's going to give you x squared plus 12x plus 7x, right? 3x plus 4x plus 12. If you're confused by that, just foil it out on your own and you'll get this, okay? So what is that going to look like? Illustrate with a diagram. That's hard. I'm just going to do this. X, X, plus 7x, and then plus 12. Which will be 3 by 4, so 3, come on now, by 4, uh-oh. Okay, got it? Alright, the original square block was extended by 4 inches only on one side. So this is x times x plus 4. And another way to write that would be x squared plus 4x. This would be x by x plus 1, 2, 3, 4. Okay? Got it? The original square block was extended by 5 inches. Well, that's just going to be x squared plus 5x, right? And I'm going to save, yeah. Whoa, what is that?
I think I made a mistake.
Here we go. The original square block was extended to 2 inches on one side and 6 inches on the other. Well, here, let me, I guess, draw this better. I'm going to draw this first. Here's the original square block. We went 2 on that side. And 5 on the other. So this is going to be x squared plus 5x plus 2x plus 10, right? So just doing this in a different order. But now this is like what the foiling is actually doing. So this is going to be x plus 2 times x plus 6. Uh-oh. Oh, I did 5 on the other. Dang it. Dang it. So this should be 6x. And this should be 12. See it? I did that wrong. So this would be x squared plus 6x plus 2x plus 12, or x squared plus 8x plus 12. This is how they want you to write out the rectangles. I was writing them out incorrectly before, but no big deal. All right, let's pause and read. Got it. Now we're going to do the opposite, Carson. We're going to go from the adjusted order to the adjusted, I guess, binomials. Okay? Unfoiling, which is called factoring. Okay? Just a very important term that we're about ready to start doing every day. Factor equals undistributing. Okay? So this has been distributed. What do you think happened to our original square here?
There was 5 on the bottom.
So we added 5 to the bottom.
There's 3 on the top right.
And we added 3 to the top right.
And then our leftovers.
And we had 15. Exactly, exactly. So this came from... Okay, this is what they're looking for. That is factoring. Okay? What did this come from?
X plus 4 plus X plus
This one.
X plus 9, X plus
This one. Got it? Okay, moving right along. Now, this is where it gets a little harder. If this is a 10, we know that we multiplied to get 10, but we added to get 11. So how should we break that 11 up so it looks like this? Give me two numbers that multiply to be 10 but add to be 11.
7.
Nope. See how I did that? They multiplied to be 10, but added to be 11. Those numbers are 10 and 1, right? So what was our original one? X plus 10 times x plus 1. It's the only possibility. So now give me two numbers that multiply to be 10 and add to be 7. Excellent. 2 and 5. Do you see how all I did was split the middle up? So then what are my two things multiplying by each other? Got it? Okay. Multiply to be 8 and add to be 9. Right? Multiply to be 8 and add to be 6. So this just shows that this is a case for many people your age. You got to know your math facts, your multiplication tables, and your addition facts. Okay. So then, what's the FOIL?
X plus 4 and then X plus 2.
X plus 4 Come on now. Times x plus 2. So on the rest of these, I'm going to go straight to factoring. I'm not going to include this step anymore because most math teachers don't do that. So give me two numbers that multiply to be 12 and add to be 8. 8 times 4 is not 12. Two numbers that multiply to be 12 and add to be 8. 4 and 3 is 7. X plus 6, x plus 2. Give me two numbers that multiply to be 12 and add to be 7. You just had this one. Now hold on, what if I had x plus 4 times x plus 3 if I reverse the order? Are we allowed to multiply things in any order we want? Yes, we are. So this and this are both correct because they are the same thing. So that's important to know. You might have it different than me and still have it correct. What about multiply to be 12 and add to be 13? There you go, Carson. Okay. All right. What relationships or patterns do you notice when you find the sides of the rectangles for a given area of this type? We are looking for two numbers. Okay. They multiply to be C, and they add to be what? They add to be B. Remember, we generally call these AX squared plus BX plus C. Okay? Got it? Any more? All right. The customer called and asked for a rectangle. Given area. The customer service said that the shop couldn't make it. Do you agree or disagree? How can you tell if a rectangle can be constructed from a given area? All right, what are all the ways we can multiply to be 9? 3 and 3. That leads you to 6, so that's not it. 9 and 1, right? That leads you to 9. That's not it. I mean, that leads you to 10. To 10.
What about 3.5?
Okay. Well, I don't think we're going to make any rectangular patches with partial units. So, I guess how can you tell if it cannot be deconstructed? You need to check all factors for C, the last number. Okay? That's it. Boom!